Hello, Mr. Thompson here with a video math lesson. Today talking about Pythagoras Theorem and applying Pythagoras Theorem. In other words, using the Pythagoras Theorem in word problems. Okay, so there's a few steps when you have a word problem that involves Pythagoras Theorem that are important that you need to make sure you do. So we'll go through those steps and then we will look at an example. Okay, so the first step is to identify and draw any right triangles in the problem. Okay, they will typically, sometimes word problems will have an illustration with them and you can look in there and try to find right triangles, or you may have to create your own drawing and then find the right triangle within that from the information given. Label the sides of the right triangle with their lengths that you know, and for numerals for the unknown sides. There will usually be one or another side that you don't know, and you can label that with, you can use A, B, or C, the traditional Pythagoras theorem for numerals, or you can use another symbol if you so desire. Next, use Pythagoras theorem to solve to find the unknown lengths. And then sometimes that's the answer, but sometimes you need to do more work, so do any other necessary calculations. And then answer the problem with a full sentence. So answer in words with a full sentence. So there's the steps. Let's look at an example. So in this example, we're going to look at two buildings that are built 25 meters apart and have a cable linking their tops. So a cable from the top of one building to the top of the other. One building is 50 meters tall and the other is 80 meters tall. So we're asked to find out how long the cable is. Okay, so maybe this comes with a drawing, maybe you have to make your own drawing. So here's two buildings, and one of them is 50 meters, one of them is 80. We know they are 25 meters apart. Okay, and we want to find that length of the cable. Okay. So the first step is to identify any right triangles in this problem. And there's our right triangle right in here. Okay, from the top of the building down here, and then across, and then anytime you go straight across and straight up, you get a right angle. So there's a right angle triangle just right there. Okay, and what we want to do now, you might think, well, okay, there, I've drawn my right triangle. Well, when you draw it in amongst these buildings and other figures and things that you might, maybe there's other numbers here that you don't need and things like that on certain problems. What is best to do is if you draw it separate. Draw it out where you can have really clear labels and not all the clutter. Okay, so now I've redrawn it. I may or may not have drawn this really perfectly, okay, and it doesn't necessarily matter, okay, as long as all the sides are in sort of the right place and things like that, and the numbers are right, then it'll work out. Okay, if you like to draw things really to scale and perfectly accurate, then you can do that. I mean, having graph paper helps, but this one, I did it fairly quickly, and it's not necessarily perfect, as you might sort of notice as we go through. The numbers things might not look right, but as long as we follow the numbers and do the steps correctly, we'll be okay. So now we need to label this triangle with the sides that we know. Okay, so first of all, we know the bottom is 25 meters. Okay, we don't know the top, right? So that's the side we don't know. Okay, sorry, the hypotenuse we don't know. We need to find that hypotenuse. We know the bottom, as I said, is 25. Now this side here, we don't necessarily know exactly, this section of building, but we know that the top building was 80 meters high. The bottom building was 50 meters high. So this is from 50 up to 80. So 80 minus 50 is 30. Okay, so we can mark that as 30, and I'll just erase everything. And most of you could probably do that in your head and just realize, from 50 up to 80, it's 30. So now we have two sides of the triangle, and we need to find the third. So we can set up our Pythagoras theorem. We know the two legs, so we'll put those in for A. We'll say A is 25 and B is 30, and now you'll see, oops, skipping ahead, that's all right. You'll see how this triangle is not necessarily drawn to scale because this side looks shorter than this side, but it should have been drawn maybe longer. But again, it doesn't really matter as long as we follow the numbers carefully. Okay. So you can see I've squared 25 is 625. 30 squared is 900, so I'm going to add those together. 1525, 1525, that's equal to c squared. So now I need to take the square root of both, and the square root of 1525 is approximately 39 meters. It's like 39.08 or something like that. So I've just rounded it. You know, the instructions didn't say. If the instructions said round to the nearest centimeter or to the nearest 2 decimal places, I would have to do that. But it didn't, and I'm pretty happy just rounding it to the nearest meter. I think that's probably good to go. And then I've answered in words. There was no other calculations to do. That's giving me the answer. How long is that cable over here? So I've answered in words. The cable is about 39 meters long. And as long as the problem didn't ask for a certain precision, a certain, significant figures or whatever, I'm right to round it as I sort of see fit. Okay, so there you go. That's one example problem. If you would like to see more example problems, feel free to leave a request in the comments or email me or whatever you need to do. All right, so good luck, and we'll see you next time.